automation has been brought up a whole lot. Let me talk a little bit about what I mean by automation and what it looks like in a testing plan. So the first thing we want to know is, when do we automate? Um, Ideally, if we can write automated test cases from the beginning, it means we always will be testing using something we will never have to do by hand again. Um, Part of it is, when we write automated test cases, we need to also debug those test cases. So the earlier they're out there, the better. I'm actually, in a perfect world, a fan of the idea that I write the test cases alongside the code, and can even save the developer some time of, oh, you got that code almost done, here's some test cases, try this out. There's a whole methodology called test-driven development, which partially does this idea. It's like to say, hey, your test cases are co-evolving with your code. It's also partially a design methodology. Like, what's the basic approach to get the minimal yet satisfying solution, from that. And so it's a whole different ball of wax, but we'll talk about that. But what we do need to talk about is, how do I automate? How do I get to these ideas? So automation frameworks is one of the keys inside of here. There's all sorts of software tools that will help us to automate this. Some are developer tools, some are tester tools that can help me do this sort of stuff. I'm going to focus a little bit on developer tools because this is more of a software engineering curriculum. We don't really have a testing curriculum, though some of you might be focused on that. But these tools can be used by anyone. So JUnit is the typical Java tool that's going to be used. There are also things called NUnit for .NET, and I think there's a Python version, and so there's all sorts of versions of this. I'll talk about the Java one because that's what I'm most familiar with, though I have played with the other ones. This is a unit testing approach that really is around testing web services, databases at the code level. You see it's junit.org. So the idea of JUnit tests is it gives us a framework to do the heavy lifting of running test cases. It sets up the input data through a structure for that. We still have to design it and code a little bit of that, but it gives us a place to set up input data. It gives us a place from which we call features. It gives us a place and a bunch of tools to be able to check the results and then report them back out. So it takes away us having to design all that and gives us a framework by which we can construct and execute tests. So the idea behind this is I have some base classes, like a test case class, that I extend out, and each method that does a test has something called like a test add in here. You can see the name test add. And then I set up some data, I call some method, and then I have this idea of this assert. And the assert is saying, I say that the sum based off of the result I got back here matches the total, which is predefined here. So 3 plus 2 is equal to 5. Very, very simple test case. But the idea is, if it doesn't, then we have a reporting mechanism by which things are failing, and we get notification of that. And so it looks kind of like this. When I run the JUnit test, it'll say, here's the big level test, math operations tester, and then it has a test add, so test subtract, test multiply, test divide, test whatever the different features are, and it tells us not only did it pass or fail individually, but how long did that test take. So we could actually say, oh wow, it took 4 seconds to run an add fail test, so it passed, but something's wrong there. This is based off of an integration with your IDE, NetBeans or Eclipse or something like that. So it makes it pretty easy to develop and run these tests at the same time. Even better, I can have these tools integrated with my build environment, and that gives me something called continuous integration. So if I build a test to test my code, and somebody else goes off and changes something, maybe something I'm dependent on, or even my code, my test can run every time somebody checks in that code. And if for some reason my code doesn't work anymore, then it immediately gets flagged saying, hey, it's broken. And so I can do that as part of my build and deploy solution. So as I said, you check something in, I check it out, and I can know instantly, the second somebody thinks they fixed something or added a new feature and checks it into the system, whether it really works or not. And so that instant feedback will let us know for every single change in the most rigorous of environments whether or not that change is net positive or possibly negative towards the total code base. If all the tests still pass, theoretically I regression tested that instantly and I should be good to go. It could be the tests are out of date. There could be problems elsewhere. But based off of the last quality measurement that I built into the system, everything's still working. So this sounds great, doesn't it? Why doesn't everybody do it? Well, you get feedback on tests, yes. You can test all the time without too much extra manual labor, and you can really have some good ways to prevent new people or accidental people or late night workers from breaking the code. But you do have to go off and write all those tests. You do have to basically make sure that every single test passes every single time. If something fails, I either have to go back and fix the code or fix the test or something. And that takes time, and it's like, oh, that test doesn't matter. And so you turn it off, and then all of a sudden none of your tests are on anymore, or things are failing all over the place. And that does happen all the time. And every time a requirement changes, I have to go through and fix the code and the test cases. And sometimes if I get too detailed, and this is where white box and black box becomes important, I might, if my tests are too tied to a specific implementation, I might break the test all the time, even if I'm still meeting the requirements. So I want my testing, maybe even at the unit level, to take a black box approach, because I don't need to test exactly how something happened if I can just test that it still fundamentally works. If I do every single line of code must behave a certain way, then that means I have to always know what the lines of code are and have my tests always reflect what the lines of codes are. And so this is why we have people. You can scale up from here. You can do tools like Selenium is another tool, which allows you to record user actions. The thing about recording user actions is it's often difficult to replay. I still have to, if you have a test which adds something to a database, like add a new user account, I typically can't do that a second time without confusing my system. So I'm going to have some level of data management and controls. And so I think we talked before, I can either plan my tests out that I add something, delete something, or I have to refresh my database, or I have to do some level of coding. You are taking this class, you are taking coding classes, whether you're going to be a coder or not, to understand design of systems. And testing is a form of system design. How do I automate this, and what's the trade-off between the long-term benefits of having automated testing versus the short-term demands of building those things? Is my team capable? Are my tools capable? Is my schedule and budget capable of taking on this idea of test automation? So I'm hoping I'm making a convincing case why you should do it, but I'm hoping I'm also making a case that you need to measure when it should be appropriately done and when maybe you can skip over parts of that as well.